As Professor Imamura mentioned, in the history of advances in tsunami warnings, research, mitigation practices, probably the most important thing is lessons learned from the last tsunami. And the 2011 Tohoku tsunami was indeed the most documented tsunami ever. And that was in large part due to NHK's incredible preparation to record a natural disaster as it was unfolding. The videos that were supplied by NHK have been used by researchers and everybody across the world to show how horrific and how powerful tsunamis are. So it's with that backdrop that I'd like to begin my talk today by reviewing some of the underestimated and some unidentified tsunami-related hazards from the Tohoku tsunami in 2011, and see if we can use these to refine our existing practices. So I hate to start off this session with talking about deaths, but I think it's important because in my talk today, I want to emphasize surviving the tsunami is paramount in mitigation practices. So the human impact of this 2011 Japanese tsunami was about 19,000 casualties, about 2,600 people missing, about 6,200 injuries. Now, one thing about these numbers that's striking is that for every person injured, 3 people died. Let me repeat that. For every person injured, 3 people died. Most natural disasters, it's the opposite. There are many casualties, there are many injuries, but fewer casualties. So the takeaway message here is if you're engulfed by the tsunami, your chances of survival are very slim. And one of the features of this particular tsunami was that for the first time, forensic research was done on what happened to these people and how did they die? Well, about 93% died from drowning. They were hit by floating objects, hypothermia, or swallowed dirty, contaminated water sediments. About 4% were crushed to death. 1%, or about 200 people, were burned to death. 2% unknown. But one of the other striking features is that in the following decade, hundreds died from tsunami-related illnesses, primarily Tsunami Lung. These were people that were engulfed in the tsunami and survived, but they ingested some of this toxic sediment. It lodged in their lungs, and they suffered respiratory problems until they ultimately died. So let's talk a little bit about the underestimated tsunami hazards. The most striking thing about this tsunami was a number of fires. Inomoto in 2019 wrote a paper, and in this paper, I was struck by his finding that according to the Comprehensive Survey of the Japan Association of Fire Science and Engineering, a total of 159 tsunami-related fires occurred. But the specific origins could only be determined in 56 cases, which means 103 cases, the fire origins remain unknown. His hypothesis is that it's possible that methane was released from the seafloor during the shaking of the earthquake, and it released these bubbles to the surface, and the tsunami brought these bubbles ashore, providing some material for combustion. This is a sequence that was recorded for Notori, Japan. And then later in the evening, as Notori started to catch on fire, you could see that the island in the top photograph expands to the whole island in the bottom of the photograph. This is a remarkable amount of fire, and it engulfed the whole area. And there's one other piece of evidence was in the 1896 Tohoku tsunami. As customary, woodblock prints were made to raise money for the relief effort. And then clearly in this Tohoku tsunami woodblock print, there are fires present. So I think that Professor Inomoto is onto something here, that there may be a source of combustible material that we've not identified before. Other underestimated tsunami hazards are forces. Because the tsunami would stir up the sediments, it then became more of a mixture of sediments and water, and that extra weight from the sediment going at the same velocity created more forces. So that was underestimated. And then the third underestimated hazard that I like to talk about is health risk. Underestimated deaths due to suffocation from ingesting sand and silt. This is underestimated. So now let's talk a little bit about unidentified tsunami hazards. And for that, I'd like to identify one, a black tsunami, which was made into an NHK documentary, and where it emphasized in this documentary the people who died from suffocation from ingesting contaminated silt. And then for those who survived, they then wound up with respiratory problems, which has been labeled Tsunami Lung. And this is a famous photograph from that, of the black tsunami. All the silt, contaminated water is prevalent here. The second unidentified tsunami hazard was a silent tsunami, and this was additional tsunamis generated by underwater landslides. The 2011 earthquake was so big, it covered such a large area, and it shook for so long, about 6 minutes, that it triggered underwater landslides in the entire area. And some of these areas produced significant tsunamis that when they came ashore, they came ashore at the same time the earthquake generated tsunami waves came ashore, and it actually amplified them. It was constructive interference. And then the third unidentified tsunami hazard is hypothermia. Many people died from exposure to the cold water, especially on that March day when it was cold and snowy. So what impact would this have on existing mitigation practices? Well, first of all, with horizontal evacuation, the increased water density may sweep evacuees off their feet in shallow water, say ankle or knee-deep water. The force of that could increase the number of people who would then wind up in the tsunami. And when you're in the tsunami, then your exposure to hypothermia and suffocation due to swallowing sand occurs. For vertical evacuations, since there's those mystery fires that now we can't identify where they came from, there are a lot of fires. So fires may engulf towers, vertical evacuation towers, or the towers may collapse due to the increased tsunami forces. So then we have to make sure that these towers that are being built are fire resistant and strong enough to withstand the forces of a tsunami. Now I'd like to talk a little about what are refinements we can make to mitigation practices. Two ideas I came up with was, one, relocate people. Two, incorporate another shelter-in-place option to complement existing horizontal and vertical evacuation practices. So let me talk first about relocation. There are some problems relocating communities, as you might imagine, especially in Japan. There may not be land available to relocate communities, but this is a global problem. So in some areas, it may be practical to relocate people from one area out of the hazard zone. But a second problem may be there are laws to prevent forced relocations. In the United States, it's not legal to force people to relocate from the coastline. It's a cultural issue, but I'm sure other countries have different attitudes about this forced relocation, but it is still a potential solution to removing people from the hazardous areas. And the third potential problem is many businesses and residents want to live and work in tsunami. Now let's look at Kurosho-Choi in Kochi Prefecture, where This map shows for a Nankai Trough earthquake, a predicted inundation would be where the yellow and red and purple colors are. And you can see that's a large area. It's about 9,000 people live and work in this area. But many of the facilities are in there, like, for example, the train station, fisheries facilities, of course, right here on the shoreline, and town provided housing in here. These people have to evacuate approximately 800 meters, and they may not have time. Nankai Trough estimates will be there in about 10 to 12 minutes. So relocating a community like this may be very difficult, and it may not be possible. The second refinement I'd like to talk about is incorporating appropriate shelter-in-place structures to complement existing horizontal and vertical evacuation practices. Currently, there are two options for evacuating. One, horizontal, evacuate on foot, bicycle, vehicle to communal shelters. And in Kurosho Choi, they have upgraded their evacuation paths by making them easy to use. They put concrete pavements in and fences. They've made a lot of progress. They also installed vertical evacuation towers. These are communal towers that are on the order of 10 to 20 meters high and maybe 4 or 5 flights of stairs. However, there are problems with both options because people are either unable or unwilling to evacuate to communal facilities. Now, let me elaborate. Let's talk about horizontal evacuation. People may not be able to evacuate because they're disabled or elderly, they need assistance, it's too far from their residence, or too much time to evacuate. But a subject that's rarely talked about is people unwilling to evacuate. Now, there's a whole host of problems about people unwilling to evacuate, and this is being studied extensively in the United States, but basically it boils down to a few key points. And the number one is distrust of warning information. In 2011, the week leading up to the March 11th tsunami, there were several warnings issued by JMA, and they turned out to be what we classify as false alarms. Then on the day of the tsunami, the major earthquake, they issued a warning about 3.5 minutes after the earthquake started. Well, and they issued a warning that said it would be 3 meters. Well, the earthquake continued to shake for 6 minutes, and they then upgraded the warning, but the initial warning was for 3 meters, and a lot of people thought, well, 3 meters, I'm protected, I don't have to worry. So this distrust of warning information is a major factor in whether people will take off on a cold, snowy day or stay in their nice, warm home. Another reason people may not be willing to go to evacuation shelters is because of disease. And especially, we've all lived through the pandemic of the last year. And I think this is a very important issue. And I'm glad this is going to be discussed later in this program. A third reason, fear of safety. Are bad people in these shelters? And then, although this sounds rather silly, pets aren't allowed, but to many people, especially pet lovers, this is an important issue. Now, what are problems with the vertical evacuation towers? It's about the same as with horizontal. Unable to get there. Now you have extra burden of climbing stairs. And as we discussed earlier, fire problems may be present. And again, unwilling to evacuate, it's the same: distrust, fear of disease, fear of safety, no pets allowed. So there are problems with vertical evacuation and horizontal evacuation. A third option might be shelter in place, where you could have immediate access. That is, a shelter would be where you reside or where you work. And evacuation time would be very short. But it must protect occupants from drowning, being hit by or crushed by floating objects, being burned by fires, being exposed to cold water, swallowing toxic dirt, and contagious diseases. So one company, Survival Capsule, that's based here in Seattle, Washington, has developed has designed, analyzed, and tested using aerospace engineering technology to design such a capsule. And it's watertight, it floats to protect people from drowning, being crushed or hit by floating objects, or ingesting silt-laden water. It's made of aircraft-grade aluminum, protect from being crushed, punctured, or by fires. This is the same aluminum that's used for the airplane wing that you flew to Sendai on. And it's tough. It can tolerate things hitting it at 500 miles an hour. So this is a good product to use for this application. It's insulated to protect from cold water or fires. It has storage for personal items, food, and water. It provides shelter after the tsunami subsides, which limits the exposure to contagious diseases. Now, tsunami casualties in the past are a good proxy for what might happen in the future. So in 2011, Japan, arguably the best tsunami prepared community in the world, lost about 3% of the people who lived in tsunami hazard areas. In contrast, on the other end of the spectrum, Papua New Guinea in 1998 was not at all prepared for tsunamis, lost about 40% in the tsunami hazard zones. So the projected casualties from the next tsunami are going to be between 3 and 40% of people living and working in tsunami hazard areas, which the United Nations estimates to be about 60,000 people. So I think we need to rethink the risk reduction in human survival. We need to focus on elimination of deaths as a framework for risk reductions. And so that achieving the goal of zero casualties from the next tsunami, which was inspired by the Kuroshio town, aiming to achieve zero victims. They worked very hard in their community to have meetings, council meetings, drills to find out who could evacuate, how fast they could evacuate. And their analysis came up with the following figures. Of the 9,100 people who live within the tsunami risk zone, they determined about 753 people, or 8%, would need help evacuating. 2% would not be able to evacuate, even with family's help. So here we see between 2 and 8% unable to evacuate. That's the problem that we saw before. So knowing that in advance, then they are now faced with the problem of what do we do with this 2 to 8% people needing help? Now, people unwilling to evacuate, they did no analysis on. And no one really knows how to do an analysis on people unwilling to evacuate. We have anecdotal evidence in the United States and from the Indian Ocean tsunami of 2004, people were unwilling to evacuate because they thought their homes or their businesses would be looted while they were gone. So this unwillingness to evacuate is a problem, but right now, quantifying how many people might die from this is still a major question, a lot of uncertainty, but we do know that people are unwilling to evacuate. So perhaps we ought to provide another option for evacuation. Instead of horizontal and vertical, where there are problems that we've identified, perhaps we ought to incorporate an appropriate shelter-in-place structure to complement these existing horizontal and vertical evacuations. And in some cases, we can help them save their lives and their possessions. Thank you.